I'm glad to introduce the next speakers, Siarhei Boika and Georgii Martsinovskii from EPAM System Corporation. They are practitioners with deep background in TRIZ in high-tech domains such as Internet of Things, smart systems, and digital transformation. Siarhei, Georgii, you're welcome.
Okay, thank you very much. So let me share my screen. Let me know when you can see it.
Yes, thanks.
Perfect. So, welcome. Today we will talk a little bit about pretty interesting topic. That topic we were thinking could be pretty good to discuss on today's session. But later on, we actually decided to a little bit change it and talk about some more probably interesting things. So let me introduce ourselves. So today, because with me, we will we have Georgii Martsinovskii, who is business consultant and actually master of transfiguration, and myself, Siarhei Boika, magic practitioner in EPAM. And let us start from here. Couple words about digital transformation in EPAM and why it is so important. Because usually when we are talking about digital transformation, we are talking about the very hybrid team that actually includes all the specialties that we have, for example, in company. And in majority of areas of expertise, it is pretty critical to consider all the aspects of digital transformations. So there are more than 30 already successfully delivered projects in EPAM. So majority of things that we will talk today are based on the practice, not just pure theory. So again, digital transformation is not something that straightforward connected with usage of latest and greatest technologies. Because when we are talking about digital transformation is actually comprehensive rethinking of a business model, of organizational structure, and majority of corporate processes. Reasons for starting journey are pretty different for different companies. It could be disruption, pressure from competitors. It could be disruption from digitally born startups. It could be need of another level of scale in operations. It could be shift in the preference of the customers. It could be adaptation of the digital sales channels and optimization of the supply chain, products and services innovation, and etc., etc., etc. From another side, there are multiple technology aspects that actually enable the change, and we are trying to use them on every occasion. So it's about elastic clouds, computing. It's about X as a service, approaches, solution that might scale based on your immediate need, and actually is the way of your operations. It's about distributed data storages with almost unlimited capacity. It's about usage of artificial intelligence and machine learning that may replace humans, may optimize the loop of decision, and they're honestly working sometimes much better and with much higher efficiency and accuracy than human beings. It's about Internet of Things that actually allows us to collect data from multiple sources, collect telemetry and performance metric from any kind of source, and implement machine-to-machine autonomous operations. And again, it's about open interfaces, architecture that obviously enable integration of different solutions. Each of those is actually itself a very complicated topic. But just try to imagine how complicated things became when we are combining all those technologies and approaches with multiple other aspects like organizational design, like new business model, like changes in corporate processes. So again, digital transformation is a very complex topic. When you are changing something, for example, in a customer segment, it affects changes in technology landscape, major business function, and even organizational structure. If you're making changes in a line of businesses, it's even worse. It affects whole enterprise, user experience, customer segments, organizational structure, business function, and technology landscape. Challenges with transformation appear because we are changing complex multi-layered, multi-component systems that in fact is an enterprise with employees, business processes, equipment, assets, clients, distributors, partners, suppliers, and etc., etc., etc. Actually, we can look at an enterprise structure as a molecular structure. Everything is connected and everything in balance. Any change to any element will lead to changes in structure, chemical, physical properties, form, color, density, and hardness. So we can do blind experiments, but if you have a knowledge how it works, it's through alchemy. In other words, here's exactly the matter. Theory of inventive problem solving, or TRIZ, proposes a systematic approach to invention and reinvention. When thought it has been originally developed for technical systems, its later modification can be applied to solve business problems as well, and as well problems in organizational design and other areas of enterprises. It would be actually very interesting to look at digital transformation from the point of view of TRIZ concept. So first, we will try to classify typical digital transformation journey in terms of system evolution. Then we will identify the points for potential application of TRIZ for addressing challenges of digital transformation. As I have already mentioned, digital transformation is aimed to disruptive changes in value delivery and operational performance. And this implies transition from one S-curve to next S-curve in TRIZ terms. So, Georgii, back to you.
Thank you, Sergey. Hello, everyone. As Sergey pointed out, deployment of a digital technology does not automatically mean that we will have a success in the market. And in terms of TRIZ, we must jump to another S-curve with regard to the business performance. And this is why all the experts in digital transformation emphasize that the company must rethink, reimagine, or reinvent their businesses. And this is why we start thinking about using TRIZ as soon as TRIZ is designed for reinventing. And by the way, it's a great exercise to understand what exactly is responsible for the development limit of the legacy business model. But if we think about, next slide, please, Sergey. If we think about evolution of systems, so at first glance, it looks like digital transformation is merely a practical case of system evolution along the trend of increasing of data flow utilization. And we have a number of mechanisms supporting this trend. But in fact, it's not that straightforward because in our initial system, we usually do not have that information flow which we would like to enhance. So we have to create the information flow first. And here is a typical diagram of a typical digital solution. And when we design this digital solution, we usually go in the direction opposite to the data flow. So we start with the value, defining the value, which would address the needs of the stakeholders. Then we decide which data we need to provide this value, what kind of processing we have to apply to this data. And only at the very end, we decide which particular technology we're going to use to measure or to digitize our physical process. Let's move to the next slide, please. In real life, the scenario is a little bit different. So only few of our clients actually follows the previous approach. So the most typical situation is when they start with choosing the technology, because they believe in technology. They believe that the better technology they choose, the more successful they're going to be with their solution at the market. So they start from their business needs, and they're looking for a technology vendor, and they try to select a technology that would feed their business need the best. Suddenly, they found out that after they deploy this technology, and even though the technology technically works, they are not receiving the expected economic outcome. So they don't have the business effect that they anticipated. And this is a really critical situation, because the money has been already spent on developing the technical solution, but they still need to do something to fix the problems. The problems originate from the complexity of the business system, as Sergey described previously. And these problems mostly represent different types of conflicts and contradictions inside the business processes. And this is the perfect place, we think, for TRIZ to step in and to bring some magic to quickly fix the situation and to help the companies to finally get to the working solution and to receive the anticipated economic effect. Let's move to the next slide, please. So now let us look at a couple real cases that we have with our clients that illustrates how we address this kind of challenges. And the first case is a company that sells bottled gas. If we move to the next slide, please. The company has a number of filling plants where they fill the cylinders with liquidized petroleum gas, and then they distribute these cylinders to the retailers. And retailers in turn deliver the cylinders to the end consumers. And if we move to the next slide, our clients started from their business needs. So they wanted to reduce the operation cost by automating the inventory process. They hope to avoid loss of cylinders inside the value chain, and they would like to increase the rotation rate of cylinders to be able to serve more customers with fewer cylinders. So basically, they were looking for a reduction of their operational costs. So they implemented some technical solution based on using smart tags that are installed on the cylinders, and some infrastructure that scans the cylinders, and the solution works pretty well, but just inside the company facilities, inside those filling plants. And the problem is that the company would like to have the information about the cylinders. They would like to track the cylinders through the whole value chain, and they ran into a problem with the retailers who do not want to make an extra effort and to scan the cylinders and send the data back to the filling company. And because of this, the whole idea did not fly. And the solution in this case was to combine this tracking technology with a technology for monitoring gas consumption. And it allows the company to know how much gas is left in a particular cylinder. And if the filling company shares this information with retailers, they let them to optimize their delivery logistics and to have some insights regarding opportunities for growing their sales. At the same time, the consumers also gets a lot of benefits. First of all, they are not afraid of running out of gas anymore, and they have convenient delivery process, and also they are able to plan their expenses because based on the collected data on gas consumption, again, we can give them some help to plan the expenses. So if we move to the next slide, please, we see that here we actually shifted from just the reduced operation cost to a completely new level of service, providing continuous availability of the product, continuous availability of the gas for the end consumers. Let's move to the next case, which is a cargo insurance company. Next one, please. The company insures shipment of components from a manufacturer to the assembling company. For example, automobile parts that is delivered from east to Europe, for example, or to United States to assemble cars. And the idea of the insurance company was to use real-time information about the cargo vehicles' positions and conditions to be able to assess potential risks more accurately and adjust the insurance contract conditions. They also use information about the weather and information about some other factors that may influence, may result in delays in the supply chain. So if we move to the next slide, please. So the initial business need was increasing accuracy of underwriting and making underwriting more profitable for the insurance company. So they decided to use digital twin technology. And again, they had a similar problem. The stakeholders did not want to share data just for the needs of the insurance company. And again, in order to resolve this contradiction, we proposed to use more advanced prediction algorithms that, in combination with the data which we receive from the digital twins, would allow not only to warn the customers about potential delays, but also to give them some options for action to minimize the negative impact on their business. And if we move to the next slide, please. So again, we made a kind of jump from just traditional insured cargo as a value for the company to service for much more resilient business, which is stable even in case of some failures through the supply chain. Okay, so let us move to the next slide, please. So let us talk a little bit about some pros and contras for using TRIZ for solving the typical problems that arise during digital transformation. So the benefit of using TRIZ is that most of the problems that we see during our projects with digital transformation is related to different conflicts and contradictions, and TRIZ has great tools for resolving, for contradiction resolving. Second point is that we can use the same instruments for both for solving technical and for solving business problems. And today we just talked about mostly about business problems, but also in this kind of projects we face very often some technical issues related to deployment of specific technology. And another very important bonus of using TRIZ is that we are able to find solution in the super system. And we know that in case of a problem with a number of restrictions, and this is a typical case for digital transformation, just because we are dealing with really complicated systems. So the most efficient solutions are in the super system, and the holistic and systemic nature of TRIZ allows us to identify these potential solutions very quickly. So what are the challenges of applying TRIZ to these digital transformation projects? The first challenge is that the problem solving is just a small step in the development process. And whatever methodology we use, it has to feed the development framework. And our development is usually agile, and it goes in relatively short sprints. So it means that we have to figure out how to adjust traditional TRIZ approach, where we have a certain analytical stage that in turn requires some time to learn the context to do this analysis. So we have to figure out how to make this productive and meaningful when applied in very short iterations. The other challenge is that TRIZ mostly deals with the system which are designed to perform certain functions, and TRIZ considers systems as a set of functions. And in business challenges, there are very often we have to deal with humans who may not easily be reduced to a number of certain functions. And in these cases, we need to combine TRIZ with some other methods like service design or similar, just to account for human factor more correctly. Okay, good. Let's move to the next slide. So we are approaching the end of our presentation, and the most interesting question: what is going to be next, and what kind of problems or challenges we may expect in future? We see that the environment is quickly changing, and sometimes these changes are pretty dramatic, like corona pandemic, but in general, all the life cycles of solutions, products, and services shorten. And it means that we have to accelerate in terms of developing new solutions. And even if we look at the very conservative industries like space industry, we see that they also accelerate. And on the other hand, customers' expectations are constantly growing. And customers expect more and more innovative products and services. And for example, every time when Apple introduces a new model of iPhone, the customers complain that the difference is not big enough compared to the previous model, because they expected something really, some dramatic changes, some really disruptive changes in every new product or new service. So it means that
5 minutes.
Yeah, thank you. So it means that the digital transformation must be a continuous process. So we need to be able to provide a pipeline of ideas for business transformation, and potentially TRIZ can be the instrument that we can use for creating such a pipeline. Thank you very much, and you're very welcome to ask any questions.
Thank you very much, Sergey and Georgi. And I'll start not from the question, but from the opinion from Alexander Sidorets. I agree, Georgi. Some experience on my side regarding ROI from tech rollout across various business areas. One of the problems is that they implement digital solutions without reinventing business model itself. You can make some comments about this opinion, please.
Yes, that's obviously true, because when you're changing something, for example, in sales channel, it's pretty obvious that you need to change the approach how you're working with the clients as well, and it may lead to changes to how you're working with internally, how you're handling all the requests, and etc., etc., etc. So it's kind of cumulative change. When you're changing something, you need to change everything.
Mm-hmm. Thank you. And the next question from Hans Gert. What is the role of semantic technologies in your digital transformation projects? If important, which main semantic technology tools are used? Is the evolution tree systematics of the Nikolai Shpakovsky helpful for your transformation journeys? So maybe this separates 3 questions. And the insurance example, how did the insurance company convince the customer to share data? Maybe you can see in...
let's start one by one.
Yeah, let's start from the last question,
okay,
because this is easy. Yeah, so they convinced their customers to share data by offering a service based on this data. So in return to shared data, the customers get an opportunity to first be aware of potential delays in the supply chain, and also to have some recommendations on action that they have to perform to avoid some negative impact on their business.
Right,
thank you.
And just want to continue the answer from Georgi. And actually, just imagine the change. It's dramatical change overall in a business model, because originally insurance company was focused on particular set of services. And today they are providing kind of a continuous service, continuous monitoring, and it benefits from that for both, for insurance company, for a client. Because for insurance, if they can prevent any damage and any issue, any exception cases on for example, on the production, on the logistic, and etc., they don't need to pay insurance costs. And of course, for a customer, if they have that service, they can make sure that everything goes smoothly without any interruption for their own customers. So it's kind of a win-win situation.
Okay, thank you. And maybe let's return to the question about semantic technologies and its role, the role of these technologies in digital transformation projects. What can you say in this question?
Well, we are not using much of some semantic technologies yet. And usually just some systematic approach to analysis of the problem and just simple methods for contradiction resolution are sufficient to address most of the problems. And although the initial challenges look pretty complicated, the essence of the problem is very often pretty simple, and it just needs some effort to analyze it properly. So probably in future we may need to use semantic technologies for solving more complicated problems, or for providing that pipeline of potential ideas for business transformation.
Thank you very much. We used all time for this section, and we have several questions in the chat. I think colleagues will answer to these questions.